All right, we're going to finish up 11.2 today, and that's all we're going to do. You will have 40 multiple choice questions to do. If you're in here today, obviously, you have a little while to do them. If you're not on the Zoom, you have until midnight to do them. Okay. I'm going to split this up so that you have your multiple choice. I'm not teaching very long at all. Okay. We're almost done with this section. It's like a page and a half. And then you'll have your multiple choice to do for the rest of the period and make sure that that gets turned in. And then you won't have that part of your test come Thursday or whatever. So then Tuesday and Wednesday, we'll focus on 12.1. And then Thursday, you'll have another part of your test. Okay. So very good. All right. So conditions for performing chi-square test for independence. So remember, we talked about the difference between independence and homogeneity, but I will tell you that again in a minute. The random condition is the same. The 10% is the same. And remember, the large count is at least 5. At least 5. Okay. That's all that goes on that page. We're going to flip it over. And then just to remind you at the top up here, independence is 1 sample . And homogeneity is 2 samples. And it could be more than 2 samples. It's just more than 1. I guess I should have just said more than 1 sample. So suppose the conditions are met, you can use the chi-square test for independence. To test, your null hypothesis. There is no association between 2 categorical variables. In the population of interest. So before it was, there is no difference. So homogeneity is the difference. If we look at this, what you're going to change in your hypothesis is you're going to talk about the 2 different variables. And then you're going to tell your population of interest, whether it's high school students, college students, ages 23 to whatever. Okay, so that's what they're talking about. And we'll see that in one of our examples. And then our alternate hypothesis is the same exact thing, except for there is an association. And then all of the exact same. Another way that you can state it is that 2 categorical variables are independent in the population of interest. Or your alternative 2 categorical variables are not independent in the population of interest. And again, you would replace the two categorical variables with what they are and the population of interest with the actual population that you pulled from. So we're going to start by finding the expected count. And that's no different than what we've been doing. And then calculate the chi-square statistic. So it is the sum of the observed minus the expected squared over the expected. And remember, we just put it in our calculator. So I don't make you do this because sometimes there's lots and lots and lots of data. So I don't make you do it by hand. We just do it in our calculator. We do have to calculate the expected values. How do we calculate the expected values?
The row total times
Row
the
times column
total.
over table total. Very good. Okay, so we're going to be doing that at some point today. Where the sum, I don't even know what this is. I don't know what this even says. I think it is of all the cells in the two-way tables. If H sub O is true, the chi-square statistic has approximately a chi-square distribution with the degrees of freedom equal to, remember to define degrees of freedom, number of rows minus 1 times the number of columns minus 1. And you don't have to know the difference between rows and columns because when you multiply, it doesn't matter. Okay? It doesn't matter what order you put it in. The p-value is the area to the right of the chi-square statistic under the corresponding chi-square density curve. So in the next example, it gives you the observed and the expected, so you don't have to do all that work. Okay, so it's actually pretty easy. Here's a complete table of observed and expected counts for the CHD and anger study side by side. So we already talked about the CHD stuff on Friday. Do the data provide convincing evidence of an association between anger level and heart disease in the population of interest? So in our state, we're going to have our null hypothesis. There is an association. In our alternative, I'm sorry, it's the other way around. There is not, and there is an association. I apologize. What's our alpha level in this? We don't have one, so we're going to put it in there as 0.05. Plan. We're doing a chi-square for independence. Check those conditions. Is it random? Remember in the last one, it said it was a random sample of 8474. And that was in the problem. Remember, we did it the other day. 10%. We're going to assume that 84,740 is less than the total population. And then large counts. Large counts. They're all of your expected values. So they're up here. 69.73. They're not your expected values. What are they? I don't want to put them in there. What are they? How do you get your large counts? What do you check? If what are at least 5. Okay, so how do we get, I just want to go back over again. How do we get those if like they didn't give us this? One more time. So if we're doing the CHD, we add the column, we add the row, we add the column, multiply that together over the table total, which is 8474. So they won't always give you the expected. I'm just going to have expected counts here. I don't want you to have to write them all out. Are all greater than or equal to 5. And that would absolutely be okay on the test because they give you the expected counts. They don't expect you to write them out over and over again. So then how do we do this? So we need to go into our matrix. We're going to edit. And I'm going to cover this up for a minute. What is my, what are my dimensions for the observed? 53, 110, 27, 30, 57, 46, 21, 606. Edit B. Also 2 by 3, 69.73, 106.08, 14.19, 30, 40.27, 4624.92, 618.81. Where do we go now? Is it second verse? Yeah, it's okay. Stat test. Not a problem. Chi-square test. AB, calculate. And we get those 3 values, put those down on paper, 16.0767. You don't have to round if you don't want to, that's fine. Sorry, I can't see what I'm writing. Be careful with this. It's e to the -4. So that means 3 zeros in front of it. And then your degrees of freedom are 2. Again, write it all down. And then we want to conclude with our p-value versus our alpha, so 0.0032 versus 0.05. And we know that 0.05 is greater than, so we reject our null hypothesis. So we have what? That there is an association between what? Yep. And then you want to make sure that you put it in the population of interest. If we go back, I don't remember where it was. CHD. Within people with a normal blood pressure for about 4 years. They followed that study for about 4 years. So in people with what they say, normal blood pressure. Just to finish it out. One more page, front and back, we'll be done. All right. Everybody good? The next one, they're not as nice. They don't give you the expected counts. But they give you a lot of everything else. So what I don't have on here, and I'll read this in just a second, is that on page, are we on the same one? Nope. Hold on. I'm not even on the same one. We're good. They don't give you the expected counts. I was on the next one. Many popular businesses are franchises. Think of McDonald's. The owner of a local franchise benefits from brand recognition, national advertising, and detailed guidelines provided by the franchise chain. In return, he or she pays fees to the franchise firm and agrees to follow its policies. The relationship between the local owner and the franchise firm is spelled out in a detailed contract. One clause of the contract may or may not contain is the entrepreneur's right to an exclusive territory. This means that the new outlet will be the only representative of the franchise in the specified territory and will not have to compete with other outlets of the same chain. How does the presence of an exclusive territory clause in the contract relate to the survival of business? A study designed to address this question collected data from a random sample of 170 new franchise firms. 2 categorical variables were measured for each franchisor. First, the franchisor was classified as successful or not based on whether or not it was still offering franchises at a certain date. Second, the contract each franchisor offered to franchisees was classified according to whether or not there was an exclusive territory clause. Here are the count data arranged in a two-way table. Okay. All right. Do the data provide convincing evidence that the alpha equals 0.01 level of association between an exclusive territory clause and business survival for new franchise firms? So what's our state? What goes in there? Your alternate. There is an association. And then what's our alpha? 0.01 in this one. We're going to do a chi-square test for independence if everything is met. Is it random? From a random sample of 170 new franchise firms. %. We're going to say that there's more than 1,700 new franchise firms. And there probably are more than 1,700 businesses. And then the last is large counts. And we have to figure those out. So if I were figuring out the first one with this 108, what would I do? Just the 108 right there. Yes and yes. And then divided by 170. Yep, they're all right there. So 102.74. If we do the other one, it's 123 times 28 divided by 170 would give us 20.26. To get this one, 47 times 142 divided by 170 is 39.26. And then the last one, 7.74. Are they all greater than or equal to 5? Yep. The reason that I don't just put your counts like this and I put them in the table is so that you guys can remember how to put them into your table. Because if you do it all willy-nilly, you're never going to know where they go in your table. So I like to throw them in there. So we're going to go to your matrix. I said table, but matrix is what I meant. And we're at a 2 by 2 this time. Your A is the one that they gave you, 108, 15, 34, and 13. Your second matrix is a 2 by 2, 102.74, 20.26, 39.26, and 7.74. We go to stat, test, chi-square test, and calculate. Write those values down. Our chi-squared is 5.91. Our p-value, and again, be careful on that p-value that it doesn't have an e on the end. This one does not. And your degrees of freedom are 1. We're going to test our p-value against alpha. Our p-value was 0.015. Our alpha was 0.01. So our p-value is greater than alpha, which means we fail to reject. So that means there is not convincing evidence of an association. Between exclusive territory clause and business survival. In these new franchise firms. Any questions? The last one is a little bit different, and I didn't give you the questions on here. I'm not sure why, but I'm going to give them to you in a minute. I also did not give you the Minitab output because it was a lot of numbers for one little area on it. So I'm going to give you the page number that that's on. This is our last page. So are men and women equally likely to suffer lingering fear from watching scary movies as children? Researchers asked a random sample of 117 college students to write narrative accounts of their exposure to scary movies before the age of 13. More than 1/4 of the students said that some of the fright symptoms are still present when they are awake. The following table breaks down these results by gender. Minitab output for a chi-square test using these data is shown in your book, and that is on page 718. And I'll show you guys that in a minute. Assume that the conditions are met for performing inference. Here's your first question. I'm going to give you all the questions. Why are we going to do a chi-square test for independence and not homogeneity? Why? On this one, what is it? How many samples are there? Independence is how many samples? One. So on this one, there's only one sample, where homogeneity would be two samples. So for this one, we only have one sample. To pull from. Our one sample is the 117 college students. Our B question is state your hypotheses. So what would your H sub O be? Between what? What two things were we checking out? Say it again. What are the two things that are in our chart? Gender and fright symptoms. Okay. So our alternate would be that there is an association. And I'm not going to make you write it all the way out. All right, so on part C, I'm going to have to show you my book in just a second, so just give me a minute. So this question is not going to make any sense until you see that mini-tab output, okay? So which cell contributes? Most to the chi-square statistic? And why does this cell differ from what the null suggests? And then I'm going to leave a space and go ahead and give you part D as well. This is the last question that we'll answer. We're going to interpret the p-value, which is given in that mini-tab output. So don't forget about that. We don't have to find it. And what conclusion at alpha equals 0.01 can we make? So I want to be able to show you that output for both of those. And then we'll answer both questions. Okay. And if you're not finished copying the question, I'll pull it back down in just a minute. So here's your mini-tab output. Try to get it a little bit cleaner for you guys. All right. So here's your male, female, those top two numbers, 7 and 29, those are your observed values, right? The next values are your expected. So they already calculated that for you. So your expected value was 11.69, 24.31, 26.31, and 54.69. So then look at these numbers. Does everybody see those numbers? Which one is the biggest? Those bottom four numbers in each category, which one's the biggest? Bottom four numbers. So right here, this 1.88, 0.906, this one, and this one. Not expected values. We don't care about those. That's a percentage of what it makes. It's the number of how much it makes up of that 4.0 blah, 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 this chi-square statistic. So 1.8 points of that 4.028 is made up from that specific cell. Okay, so when it's talking about what cell contributes most to the chi-square, you're looking for the one that gives that value the most. So this is your actual, like, you know how you do the sum of the first one plus the sum of the second one plus, or whatever, like find that observed minus expected squared over the expected. That's what that number is. Then you add it to this one, then you add it to this one, then you add it to this one to get the 4.028. So that's what you're seeing. That's what that number is. Observed minus expected squared over the expected. All right. So we know that men with lingering symptoms is 1.883 of the 4.028. And that is your chi-square statistic. All right, so just to throw these numbers up there, because for the next one, it says, why does the cell differ from what the null suggests? We're going to throw these numbers up here. So your 11.69, your 24.31. These are all your expected counts from the other values. 26.31 and 54.69. These three don't really matter. We're only looking at this one. That's the one it's asking about. The number in the charts, the observed, is the null. Everybody understand that? This is the expected, okay? So what's it say? Why does this cell differ from what the null suggests? The null, or 7. How does that compare to the expected? Don't make it complicated. Yeah, it's less than. And the expected was 11.69. And again, that came from your chart. I didn't pull, I mean, you could find those expected values, but it was already on there. All right, so then your p-value, again, from that chart I showed you, was 0.045. I'm gonna go back to it real fast. I'm gonna take it out. So chi-square statistic, degrees of freedom, and then it has your p-value. So 0.045, that's where I'm getting that from. If we put these in, we find it. We don't have to because it gives it to us, okay? So your p-value is 0.045. So to interpret it, there is about a 0.045 chance of obtaining a random sample of 117 students that give a chi-square statistic of 4.028 or higher if gender and fright symptoms are independent. All right. So then the last thing says, what conclusion at alpha equals 0.01 can you make? So your p-value against your alpha, 0.04 is greater than your alpha. So we would fail to reject. And you don't have to put all that on there because we've already done all of it. So you don't have to put the statement or anything. We do not have convincing evidence of an association. And that is it. Any questions? Okay, I think I had everybody but one on here. Take your time on that multiple choice. I'm not saying it's due tonight by midnight, except for anybody that's not on Zoom. Clearly, you have to do yours. But take your time, and if you have any questions about it tomorrow, just ask me tomorrow for sure. Okay, is everybody good? Is that understandable? I hope y'all understand what I'm saying. I don't mind you not doing, I would do some of it. I would try to do all of it. And then Mark, any you have questions on it, and maybe I can answer those tomorrow. We'll start 12-1 tomorrow, finish it up on Wednesday, and then you'll have the rest of your test on Thursday. Okay. If you're good to go, you can get out of here.